amplitude modulation. It's basically a process in which peak amplitude of the carrier signal will be varied in accordance to the message signal. Let's understand this in more detail. Suppose we take a carrier signal as AC cos 2 pi fc t. This is our carrier signal. Now the peak amplitude of the carrier, this is the peak amplitude of the carrier. Its amplitude will be varied in accordance to the message signal. Now let's write this in equation form. The peak amplitude of the carrier. Now I will not disturb the signal. Cos 2 pi fct. I will take care only of the peak amplitude. So I can write it as 1 plus Ka cos 2 pi fct. Here you can see that peak amplitude of the carrier is varied in accordance to the message signal. Let's understand it in more detail. I can write AM signal as AC cos 2 pi fct plus Ka AC mt cos 2 pi fct. Let us assume that mt is AM cos 2 pi fmt. We are assuming that message signal is single tone FM signal. Let's elaborate this equation. AC cos 2 pi fct plus Ka AC AM cos 2 pi fmt into cos 2 pi fct. Now we know that, let's multiply by 2 and divide by 2. We know that 2 cos A cos B. What is 2 cos A cos B? Cos A plus B plus cos A minus B. Ka AM AC by 2 cos 2 pi A plus B plus A minus B fc plus fmt plus cos fc minus fmt. Now here we will use one more constant for Ka-Am. Ka-Am is equal to mu. Mu is known as modulation index. Why it is called as modulation index, that we will discuss later in detail, and we will discuss this variable later in detail. Now let's continue with our discussion of AM as AC cos 2 pi fct. In place of Kam I am writing it as mu. AC mu by 2 cos 2 pi fc plus fmt plus cos 2 pi fc minus fmt. Now I want to see this expression in frequency domain. How this AM will look like in frequency domain. This whole working is done in time domain. Now let us understand this expression in frequency domain. So what I have to do? I have to do its Fourier transform. We know that the Fourier transform of cos 2 pi fct will be half del f minus fc plus del f plus fc. So as you know that the Fourier transform of cosine signal is this, so the Fourier transform of this will be AC by 2 del F minus Fc plus del F plus Fc. The Fourier transform of this signal will be AC mu by 4 del F plus Fc plus Fm plus del F minus Fc plus Fm. Similarly, the Fourier transform for this part will be plus del F, sorry, here it will be plus del F plus Fc minus Fm plus del F minus Fc minus Fm. Now we want to represent this signal in spectrum wise. So let us represent this in spectrum. Here I am representing only the positive frequencies. Del F minus Fc, it will be somewhere here at Fc frequency, Fc with amplitude AC by 2, amplitude of AC by 2. Now for this will be minus Fc with amplitude of AC by 2. I am only representing the positive frequency part. This is AC mu by 4 at a frequency of Fc plus Fm. This will be at minus of Fc minus of Fm. So this is Fc plus Fm. Here this was Fc. This will be AC mu by 4 at frequency Fc plus Fm. Now let us represent this, the same amplitude AC mu by 4 at a frequency of Fc minus Fm. AC mu by 4 at a frequency of Fc minus Fm. Now if you represent the same signal in the negative frequency, then that will be minus Fc plus Fm and minus Fc minus Fm. The amplitude will be AC by 2, AC same, whatever here was AC mu by 4 and AC mu by 4. This is the spectrum of the AM signal, amplitude modulated signal. Now in our next discussion we will try to understand what is the power of the AM signal, what is the bandwidth of the AM signal, and more about the AM signal. Okay.